We have learned three different forms of a linear equation. Each form has its own unique characteristics. It has its own time when it is useful, but they all describe the equation of a line. So you can get your notes out if you want, but I want you to review the three types of a linear equation. So the first thing I want you to type in is, what does an equation in slope-intercept form look like? You hopefully remember that an equation in slope-intercept form, the y is isolated, and it looks like y equals mx plus b, where m is the slope and b is the y-intercept. Next, give me the equation of a linear equation that's in standard form. An equation in standard form looks like ax plus by equals c. X and y are on the same side of the equal sign. It is useful when we want to find the x-intercept and the y-intercept of a line. Now finally, give me point slope form. What is the equation of a line in point slope form? Point slope form is y minus y1 equals m times x minus x1. It gives us the slope, just like slope-intercept form, but it gives us a specific point on the line that might not be the y-intercept. Now, we have converted from standard form to slope-intercept form. Today, we're going to learn how to convert from point slope form to slope-intercept form. So here is an equation that's in point slope form. You should be able to identify a point on this line. You should be able to give me the slope of this line. The point would be 2, 5, right? This line goes through the point 2, 5, and it has slope 3. Now let's put it in slope-intercept form. This is not going to be too difficult. We're going to copy the y minus 5. Our goal is to isolate y because we have to isolate y for slope-intercept form. We're going to distribute the 3 here. 3 times x is 3x. 3 times negative 2 is negative 6. My y is not isolated. I am going to add 5 to both sides, and I get y equals 3x minus 1. So I have converted this equation from point slope form to slope-intercept form. Notice the slope stays the same as we would expect. We now know that the y-intercept of this line is negative 1. All right, the next one, I have y plus 2 equals negative 1/3 times x minus 9. I'm going to do the same thing. I'm going to copy the left-hand side. I'm going to distribute the 1/3. Negative 1/3 times x is negative 1/3 x. Negative 1/3 times negative 9. We could do that in our calculator, or we just know that that is positive, not 9, positive 3. 1/3 times 9 is 3. Okay, now I need to isolate y, so I have this plus 2. I'm going to subtract 2 from both sides, and I get y equals negative 1/3 x plus 1. So we have changed this equation from point slope form to slope-intercept form. The slope should not change. We now know the y-intercept of the line, and we have another option to graph if we wanted to. Okay, so they tell me here that a line passes through the point 8, negative 2 and has a slope of 1/4. The first thing they want me to do is write an equation for the line in point slope form. So we know that y minus y1 equals the slope times x minus x1. So when I plug in my point, here's x1, here's y1. So y minus a negative 2 is going to become y plus 2 equals the slope, 1/4, times x minus x1 is 8. So that's the equation of this line in point slope form. Next, it says to graph the line. So we know that we need to graph the point first, right? So it goes through the point 8, negative 2. So 1, 2, 3, 4, 5, 6, 7, 8, down 2. So it has this point right here, and it has a slope of 1/4. So notice I don't have room to go up 1 and right 4. So I'm going to have to reverse that. I'm going to go down 1 and left 4. 1, 2, 3, 4. I'll put my second point. We could do it again if we wanted. Notice this has positive slope. I should have positive slope. We'll connect and draw a line through those 2 points, and we're done graphing. Okay, so we've written the equation in point slope form, we've graphed. Next it says convert the equation to slope intercept form. So here's my equation in point slope form. I'm going to convert it to slope intercept form. Remember, our goal is to isolate y. So I need to copy the left-hand side. I'm going to distribute the 1/4. 1/4 times x is 1/4 x. 1/4 times -8 is -2. Okay, so I'm almost done. I got rid of my parentheses. My goal is to isolate y, so I still have to get rid of this +2. So I'm going to subtract 2 from both sides, and I get y equals 1/4 x minus 4. So this is now in slope-intercept form, which means it gives me the slope and the y-intercept. Now, look what's cool, okay? Or cool to a math teacher. What is the y-intercept of this line? It's -4, right? B is -4. So where should this line cross the y-axis? At -4. Come over here and look where it crosses the y-axis. It crosses the y-axis at -4. So we can do point slope form, we can do slope intercept form, we can interchange them based on what we know about the line. Okay, so this time they tell us that a line passes through 2 points. We have written the equation of lines that go through 2 points. We've done it with slope-intercept form. We've done it with point-slope form. The difference was with slope-intercept form, we had to solve for b. Do you remember that? We had to plug the point in and we had to solve for b. With point-slope form, we don't have to solve for b. We can just plug it in, and then we can do some manipulation to change it to slope-intercept form. So I want to show you something with this one to show that the equation that goes through these 2 points, whether we use the first point or the second point, they're equivalent equations. Okay, so it tells us to write one equation for the line in point slope form. So the first thing we need is the slope. So I want you to use these 2 points, and I want you to find the slope of this line. Okay, I got the slope was 1/3. So if the slope is 1/3, I want you to use the first point, and I want you to write the equation of this line in point slope form. You should have gotten y minus 8, y1 is 8, equals 1/3, that's m, times x plus 12. X minus a -12 would become x plus 12. Now, let's take that equation. Let's do y minus 8 equals 1/3 times x plus 12. And now I want you to convert that to slope-intercept form. Change this equation to slope-intercept form. Did you get y equals 1/3 x plus 12? Now, this is complete coincidence here, okay? There's a reason it turns out this way, but this is 1/3 times the whole thing, x plus 12, and this is just 1/3 x, and then you add 12. So be careful. That's coincidence. Those are not the same thing. Those do not mean the same thing. But this is the equation in slope-intercept form. If you missed any of that, go ahead and correct it. Now, the next thing I want you to do is we're going to write the equation again, but we're going to use the second point. So using the slope, which is 1/3, and using the second point, which is 9/15, write the equation of this line in point slope form. Did you get y minus 15 equals 1/3 times the quantity x minus 9? Now, look at this equation and look at this equation. They look very different, right? But they're both equations of the same line. We could write a bazillion equations in point slope form for the same line. All right, but look what happens. Now I want you to take this equation, y minus 15 equals 1/3 times the quantity x minus 9, change this equation to slope-intercept form, and let's see what happens. What did you get? Did you get y equals 1/3 x plus 12? Okay, so these are the same line. Even though the equation in point slope form looks very different, they have the same slope, they have the same y-intercept. So quickly, I want to show you one more thing. Copy this down and have it in your notes. This is what we did before. Remember, we used y equals mx plus b. We plugged in our 1/3 and we plugged in one of the points, right? So if we let this be x and this be y, we said 15 equals 1/3 times 9 plus b. Do you remember doing that? And we got 15 equals 3 plus b. And when you subtract 3 from both sides, we get b is 12. We get the y-intercept is 12, right? So the equation of the line is 1/3 x plus 12. So doing it any way, whether you do point slope form using one point slope form using the second point, or picking a point and plugging it in and solving for b, you get the equation in slope-intercept form, and they should all be the same thing. Okay? All right, we're ready to do a little bit of practice in class.